Aloha, Richard Halverson here. This is ICS321, and today is May 25th. Let me share my screen. Screen 2. And if we look on the syllabus, today I'm just going to talk a little bit. I'm going to introduce you to chapter 2. That's Wednesday and Friday. I'm not going to be able to have any more recordings this week, but next week and the week after are included in these 4 days. There's a holiday in the beginning and a holiday at the end. So anyway, this covers three full weeks, and that's chapter 3. That's the most important. Probably the most important part of this course is chapter 3. Chapter 2 gives you kind of the math and the theory behind databases and why we need things like join, why we break down database tables into smaller tables and so on, what we're trying to accomplish there. And so that kind of stuff is what I'm going to talk about today, but the chapter 2 does a very good job of explaining it, and I'm not going to get into too much detail just because I don't want to confuse you. So let's go to chapter 2, relational databases. Okay, so we have this thing called the relational model, the database model. Mathematically, it's the relational model. In databases, we talk about tables and columns and rows and fields and so on. In relational algebra, we talk about relations and tuples and attributes, but they're similar. They're related. The relational model came about in the early 1970s with this guy named E.F. Codd, and I took my first database class in 1972, and it was the professor just handed out a bunch of papers, and that's when I thought, gee, I get this stuff. So that's when my interest started off. But this talks a little bit about the history, terminology, what tuples are, what relations are, and so on. So you want to read through this, especially if you're mathematically inclined and you want to. This talks about relational operations. These are the operations. We're going to learn about all these and how to do them in SQL. There's different kinds of rules. So the thing about databases is it's able to enforce way more things than spreadsheets are. If you say a particular field, if an integer goes in there, you can't put anything other than an integer in there, and it'll just the database will just stop the whole thing. I mean, if you're trying to update this row and you got one little field that's supposed to be an integer, and you're trying to put a blank in there or something, it says whoa, and it stops the whole thing, and you have to get it right. So before an operation starts and at the completion of an operation on a database, all of the rules have been enforced. So they're all followed. There are structural rules and there are these business rules, and oftentimes business rules are implemented in triggers. They're programmed in by the database programmer, and we're going to learn about that in this class. So anyway, that's here's a challenge activity. It's just checks to see if you understand what a tuple is. Tuple, the order doesn't matter. It's just the fields. It's just what's in there. So which of the following is equivalent to BRB, Barbados, and Bridgetown? It's got to have a BRB in it. Barbados, Bridgetown, but it's none of these because these only have, this is not BRB, whatever. So it would only be this one, he thinks. Yeah, so anyway, you can do 2 and 3. This is the terminology for how tables are structured. There's tables and columns and rows and cells. And so click through these. You want to click through them so you get all the points and reinforces that you understand it. Then you can answer these multiple choice questions. These are built-in data types in a database, for a database table, for a field in a row of a table. And you say when you're defining the table what those fields are using these different types, and you can't put something in there that's doesn't follow the rules. You know, floating point. You know, you try to put this in a floating point thing, and it's not going to take it. It's incorrect. This is a date, so this is going to go up here. This is a floating point. So anyway, okay. So what's next? Null values. This is a unique thing in databases. Is you know, when you're building a database and you're putting in data, sometimes you don't have all the information, and so it's nice to have a special field indicator to be able to indicate that and to be able to test for it. And so a database, the value of a field in a row can be null, which means it hasn't been defined yet. You know, if it's a character field, it does not mean blank. It means null. It means we don't know yet, or I don't know yet, or maybe it means it's not applicable. So so you can and you have to be careful with null, because if you have data that can have null values, oftentimes the regular old logical expressions don't work. Like if a field is empty or a field is blank, you know, null doesn't mean blank. You know, null means undefined, and so you have to test for it specifically. And this talks about that. And so if you try to operate on you know, if there's null values in an expression, then it's, you know, that it has particular defined meanings here. And this talks about that. So make sure you understand that. So here's something you should spend some time and go through these participation activities. It's just, if you run it once, you get the points, but let's see what they're trying to teach us here. The given SQL creates a song table and inserts some songs. Some values are null. A select statement selects songs that have a null value, a null artist value. So press run to produce the result table. Verify that these two songs are the only two songs that are selected when we're selecting a null value. So this is pretty cool. This is the first time we've seen this. You know, first we create a table, and we haven't learned any of this yet. So this maybe is the first time you're seeing this. This is a create table statement, and we're going to learn about create table statements, and we're going to be tested on create table statements. We go over to chapter 3 here, and we got you know, here the first lab in chapter 3 is a create table statement we have to generate ourselves. Anyway, this is the create table statement here that creates a table called song, and there's going to be an integer ID, and there's going to be a title, which can be any string of characters up to 60, an artist, any string of characters up to 60, a year that it was released, and that's an integer value. And then we have a declaration here saying that, well, this is the primary key, and we'll learn about primary keys later on in the next section, it looks like. And here we're inserting some songs in there, and we're going to learn about insert statements. We're going to learn about inserting rows right here, and then we want to make a list. We want to list out, this asterisk means we want to list out all of the fields in the row, or all of the attributes in the tuple, or whatever, however you want to, whatever language you're using. All of them from the song table, and this is the constraint, only the ones where the artist field is null. And so when we run this, we see it creates table, inserts the songs, and so it creates the table, inserts the songs. This is what it looks like. does this query, and this is what it gets. And then it says modify the select to only select songs that have a null title value. Okay, here we select artist value. So if we just change this to title, we get the ones with the title value. And so it's these ones, title value. Now, you know, we can get fancy. We can say, or artist is null. And then we get all 4 of them, presumably. There's all 4 of them. And if we want not that, we can do this. Think. Does this work? Yes, it does. Okay, anyway. All right, so make sure you understand that. Oh, look, here it tests your ability to understand how these select statements work. I can't believe we're already talking about select statements. We're in chapter 2, okay? We really get into select statements a lot more in chapter 3. Aggregate functions. Okay, so there are these aggregate functions, and you can, it sums up a bunch of rows based on what you select. It sums them up. I was going to do an aggregate function here where I sum up the years, but that's okay. So this talks about that, how you can sum things up, and you can put expressions inside the selecting, where you specify the fields or the columns in the select statement. So this is valid. This works. So step through these. So you're going to have a problem here if something is null, and this talks about that. This is not the same. Whatever, that's not the same because of null values. And so this talks about aggregate. Yeah, this short section on aggregation, and we get a lot more into that later. This is null logic. You know, true and true is true, of course, true and false is false, but true and null is not. So, you know, this is helpful to know, but you can usually just write your where clause in such a way where if you want to include them or you don't want to include them, it's best not to have them. It's best not to have null values. All right, so what's this now? Select this value. Let's start it. Select this value from a country where area is null. So area is null is that one. So we want TL is what we want. TL. Okay, so you can do those. All right, primary keys and foreign keys. This is important. A primary key is a column or group of columns that are used to identify the whole rest of the row. So they are unique. It's defined as it's got to be unique because it uniquely identifies each row. And so oftentimes there's simply just a field called ID, for example, and it has no other meaning other than to be unique for that row. So it's better if it has no other meaning. You know, it's better that it's not something that somebody might ever want to change for whatever reason because they don't like it or something changes in their life. you know, I don't know if people can get new social security numbers, but maybe they can. If they can, then a social security number probably isn't a very good key. It's also not a good key because, you know, if it's known, it has a lot more implications than just you know, UH, back when I first started back in the 80s at UH, our student ID was our social security number. And then then when they figured out that you couldn't, that's not a good thing to do, they of course changed it to some random eight digits. So anyway, so that's what a primary key is, and every relation has a key, or has a candidate key. Why? Because a relation cannot have duplicate rows. So if it cannot have duplicate rows, then that means every row at least must be unique. And if there's no smaller set of columns other than all the columns, if there's no smaller set of columns that can serve as a primary key, then it just has to be all the columns. And so every relation has a candidate primary key, but it's best if it's just one column. And so often you just create a column, and that column, that's going to be the primary key, and the first record that goes in there is going to be number 1, and the next one is going to be number 2, and the third one is going to be number 3, and so on. And if you end up deleting them in the middle, it doesn't matter if there's gaps and all that. All right, so with the primary key, you can search just on that value for the key value, and you will get that unique row. And sometimes you have composite primary keys, like in this case. Let's say you have a table. Let's say, you know, at your where you work. Let's say they have a database table inside there it's called family, and it's got the family members of all the employees. Why? I don't know, for whatever reason. And so there you might have a composite key where it consists of the ID of the employee, the ID of the employee, and then just a number here indicating 1, 2, 3, 4 for family members. And so presumably a particular person can be in the database, in the table in more than one place, especially if family members also work where you work. Anyway, so that's a composite key, because remember, the primary key has to uniquely identify the record, and there's no single field in here that uniquely identifies a row. You know, there can be two different people can have the same name, so that doesn't work, and so on. So here it's this ID of the employee plus an incrementing number, which we're calling number, I guess, that will make the row, will make it so the composite primary key will uniquely identify one row. All right, so this tests your understanding of that. Okay, a foreign key is simply a field in a table that is a key value for a row in another table. You know, and there's a relation there. There's a meaningful relation there. So, for example, let's say you have this table of departments, and each department has got a manager, a single manager, and that manager is an employee of the place. And so this field in the department table is a foreign key. It is the employee ID of the manager. So this here is the employee. Here's the table of employees, and so the manager of the engineering department is Lisa Ellison, and the manager of the sales department is Maria Rodriguez. Also, the marketing department is Maria Rodriguez. Sam Sneed is not a manager of anything. All right. So that's primary keys and foreign keys. So you can have special cases. You can have a field be a foreign key into itself. Here we have an example of, we have employees, and then we have their managers, and a manager is an employee. So it's a foreign key into itself. So we see that Lisa Ellison's manager is Jiho Chen. And we see that Jiho Chen's manager is Null. And so in this case, it's either that we don't know who Jiho Chen's manager is, or that Jiho Chen doesn't have a manager. And in this case, I would guess that Jiho Chen doesn't have a manager. All right, so here's an example of how you have health plans. These are all of the health plan recipients in the company, and it includes employees and employee family members. Match the table with the special case. Employee manager table, we have foreign keys. Foreign keys may refer to a primary key in the same table. That'd be this one. Department staff table. Well, I know this is that one, so this must be the number. All right, anyway, so make sure you understand this. This doesn't look too difficult. You're selecting a country name, so it's going to come back as something here, and it's going to be, so these are all country names, I see. From country, that's the table, where TLD equals .si. .si is this, so it'd be Slovenia, so it'd be this one. I'm not sure what the, okay, so anyway, you can click start and do that. All right, referential integrity. This talks about, let's say they're hooked up. We have a department and employee, the manager of the department is an employee, and so on. You know, you use these foreign keys when you're joining tables together. Like, let's say you want to display out a table that's got the department, but instead of having a manager number, you have the manager name. So in this case, you might want, you might want to see the code, you might want to see the name, and you might want to see this name, and you might want to see this salary, let's just say. Okay. So you don't really care about this field, and you don't really care about this field, other than they mean something together. The manager field is actually, pointing or connecting itself to the ID field of the employee. So, all right, so you have that, and you tell the database this. You say there's a relationship here. Well, you also tell the database what happens if you want to delete something. Like, let's say you have a table like this, and then you come along and you say, well, we aren't going to have a sales department. Well, maybe we're not going to have a sales department anymore. We're going to merge it into the marketing department, and we're only going to have one department. So to save some money, we're going to eliminate the sales department. So they go in there and they try to delete the sales record here. Well, what happens? This is connected to this. So so what do we do about this employee here? That's, wait a minute, that's not a good example. Say we delete the employee. Right. If we delete the sales department, it's not a problem. What happens if we want to delete the employee? What happens if we come in here and we say, oh, Lisa Ellison got an offer at a different company, and so she's going to be leaving at the end of the month. So we're going to go in there, we're going to delete Lisa Ellison. Well, what happens to engineering? Well, you have to choose, okay? And when you're defining the connection, when you're defining this foreign key is actually, you know, the primary key of this other table, you have to say what happens if this employee gets deleted. Well, what can happen? One thing you can do is you can say, well, everything associated with Lisa Ellison gets deleted also. So we're going to delete the engineering department also. Okay, so you could do that. In this case, you probably wouldn't do that. You're probably going to still have an engineering department, but there can be some other things like, let's say you have some, you know, some files on the server that are related to Lisa Ellison, and you're going to delete Lisa Ellison. And there's some files over there. There's a table that's linked to it. Anyway, in that case, you probably would go ahead and delete the files. Okay, but anyway, so you can either delete engineering, or you can make engineering be null. You can say, well, you know, there is no 2538 anymore. We got to put something there. Let's put null. Okay, so you put null there and say that, do that, and that's entirely possible. Look, tech support doesn't have a null. It doesn't have a manager yet. And so this cannot have a manager. The third thing you can do is you can just say, sorry, you can't delete Lisa Ellison. You got to go take care of these other things first before we will let you delete Lisa Ellison. Okay, so that's a third kind of rule. Anyway, so this talks about the different kinds of rules and when and why you have certain rules. This so they can be this is how they can be violated. You could also go in there and let's say for whatever reason, let's say you decide you're going to change Lisa Ellison's ID. You got confused. Personal got confused. It turns out that two people have the same ID or some such thing, and so Lisa Ellison's ID has to change. Well, what happens to this? Does it change, or does it stay the same, or does it become null, or what? So when updating occurs, that's when you have to you know, you have to say, when you make this connection, you have to say how you want that to happen. All right, so this talks about that. These are the options. These are the options of what I just talked about. For updating, you can cascade, you can set it to a default, you can set it to null, you can say, sorry, you can't do it. So make sure you understand that. Restrict referential integrity. What happens if a row containing Pakistan is deleted from the country table? Restrict. Oh, you have to know what restrict is. So we're going to refer back to, well, I think I can remember where it is. Okay, so let's start this. What time is it? It's getting late. Okay, with restrict referential integrity, what happens if the row containing Pakistan is deleted from the country table? Okay. What happens if this is deleted? Well, we have a problem because we've got this here. Restrict would probably mean it doesn't happen. Yeah. Restrict. rejects the insert if it violates. Okay, so yes. Well, what happened? The delete is rejected. Yeah, what's next? With set null referential integrity, what happens if the ISO code 2 of China is updated to XX? Okay, so ISO code 2 for China, change this to XX. Well, then what happens to this? What happens to the ISO code 2 if XX is updated to ISO code 2? It is updated. I think it's updated. However, this is set to null. That's what I think. Set null. With set null referential integrity, what happens when that happens? So I think this goes ahead and gets updated. However, this one turns into a null. Let's see, is that right? Yeah, it is. Okay, we can do the rest of them. All right, so now we're going to start using the connection to join tables together to get bigger tables with only selected columns. There are different ways that we can do that, having to do with if there are rows that aren't connected to, if there's rows in one table that aren't connected to the row to any row in the other table, what happens to those rows? Well, if it's inner join, then they aren't displayed or used. It's only rows that have a connection to the other table that are included for inner joins. And then for outer joins, it depends on if you're doing a left join or a right join. And it's some of the, if you're doing a left join, then all of the rows in the left table are included, but there could be some of those rows may not have a connection to the right side table, and then there will be nulls in the foreign key fields. Anyway, you go through this and make sure you understand it. I'm not going to confuse you any more than what I just did. But so we have inner joins, left joins, right joins, and full joins. And let's see, here we have an inner join of department and employee on this number. And we see that for an inner join, because technical support does not have an employee and because Sam Snead is not the manager of any department, those two records don't appear in the final table. So, however, if we have a full join, then those fields do appear in the final table. It's just that the other side is null. So when Sam Snead gets put in, the department name is going to be null because Sam Snead's not the department head of the department. And technical support is going to be in there, but it's going to have an employee name of null because there is no employee that's connected. So that's the difference between that. And in left and join, you see that's what I was just talking about. The most common one, from my experience, is left join, because you've got a whole big list of, let's say, voters, and then you're going to left join all your list of all the information that you have on voters. But some voters you don't have any information on, but you still want those voters in the list. But then other voters you do have information on, and so you want to join that information in. So that the left join is really used a lot in many scenarios. All right, so make sure you understand that. Here it tests you. Okay, if there's nulls on both sides, that must be full. Null here and a null here, that must be full. And if there's just nulls on the left side, but not on the right side, that must be a right join. And if there's nulls on the right side, but not on the left side, that must be a left join. And oh, look, there's no nulls, that must be inner. All right, So anyway, oh, there are these other kinds of joins having to do if they're not the self join. That's when you got yeah, you have to use aliases. So this employee manager thing, you have to use aliases because you have to be able to keep track of. You're talking about the name of somebody. Is it the manager you're talking about, or is it the name of the employee itself? So you have to use aliases and stuff, and this tells you how to do that. It shows you that example. Cross join. There's these other joins, kinds of equijoins and non-equijoins and so on, where you can use less than or greater than. We're not going to do any of that in this class, but just know that you can do that. All right. What time is it? Oh, it's getting pretty late. Okay, so I'm not going to go through any more of these. We are on 2.7. Okay, there's a view. A view is simply a select statement. When you execute a select statement, you get something that looks just like a table, right? Well, you can create these views, which are actually just stored select statements that have a name. And you can use that view that's got a name. You can use that as a table because really it looks like a table. So this is how you have this concept of closure, where you have a select statement, select something from a table, but instead of having a table, you have a view, and a view is actually a select statement. Anyway, that's what this is. Nice thing about views is when the tables are updated, the view automatically gets updated because the view isn't. The table from the view is not generated unless the view is called to action. Anyway, so your second assignment is going to have you create some views. You can use views to do other things, but I only use views for as tables. All right, so make sure you understand all this stuff. I'm not going to confuse you. Some of the stuff I don't use, so I kind of don't want to confuse you too much. All right, normal forms. We're at the end of the chapter. This is well, this is very important. These normal forms are very important. It's very important that you understand how to define, how to know if you have a table there, how you know what normal form the table is in, and if the table has to be reduced to a higher normal form. And when you reduce a table to a higher normal form, you're splitting it up into smaller tables. Okay, and so there's this process where you start with a table and it may be in first normal form, and then you split it and split it and split it until you end up with something in Boyce-Codd normal form. Okay, depending on the nature of the data, you may have to go further. You may have to go to fourth or fifth normal form. Usually you don't. In assignment 2, which I'm going to talk about next week, after you've gone over 2.8, this section 2.8, the next assignment is I'm going to present you with tables in first normal form, and you have to reduce them to higher normal forms. And the last 2 tables are actually, you have to go all the way to fourth and fifth. Okay, but they'll be obvious. The point of the assignment is when you look at it, you go, oh yeah, there's still, it's in, if you look at it and say, oh, is this in Boyce-Codd? Yes, it is in Boyce-Codd. Well, there's still redundancy in there. I can still make a mistake. And so you end up having to reduce it more. So when you do reduce down the Boyce-Codd, if you have to reduce it more, it's obvious. And then you might not know about, you might not be thinking, oh, it's got to be fifth normal, but you'll see what you have to do. Same with sometimes you might leave it. Sometimes you might leave it in third normal form. Sometimes you might even leave it in second normal form. And I can think of some cases where that is. So anyway, make sure you understand this section. Go through this section that it talks about first, second, third, and Boyce-Codd. Doesn't talk about fourth and fifth. I'll talk about fourth and fifth when I give you the assignments. And then this last section here on relational algebra. This is the mathematics behind, this is the mathematics that explains relational algebra. And when you go through this, all they've done is they've taken all these things that we know about databases, that we talk about with databases, and they've assigned, you know, these Greek symbols, these symbols to these things, to these operations, and then they have a way of expressing. So all of the select statements that we write, there's this mathematical expression, confusing way of writing this. And I know none of you is a PhD in math, but after this, you might think that maybe you should be. Really though, this is kind of what you might say separates the computer scientist who may go on and get a master's degree with the Bachelor of Information Technology who gets a 4-year degree in computer programming from West Oahu or something, where you don't have to take as much math. You don't really have to understand databases at all using this nomenclature, this terminology, but it's actually helpful, and it kind of helps you see the big picture, that it all really boils down to this math that Al has to sort of work out, and has got, you know, history to it and everything. So go through this, make sure I don't believe, yes, there are some challenge activities in here. Really go through and make sure that you understand this section and try to get all the points, but you're not going to be really tested any more than what you get in this section. All right, so that's kind of covering chapter 2. I'm not going to talk too much more about this, except for when I go in to explain the assignment, I'm going to go over the normal forms a little bit more, so you can kind of see what you're doing. So anyway, that's it. Thanks for watching.